Welcome to Lesson 7, Scheduling, the quiet decision that shapes everything else in your cluster. The kube-scheduler's job sounds trivial. Find a pod with no node assigned, pick one, bind it. But that single placement choice is the lever that controls cost through bin packing, availability through zone spread, performance through hardware matching, and isolation for your sensitive workloads. The default scheduler is genuinely good. Your job as the platform engineer is to tell it what to optimize for. That's what we'll learn to do today. To get there, we'll work through 4 mental models that map directly to the SRE loop. First, observe the scheduler's 3 phases: filter, score, bind. Then diagnose, because a pending pod is never a mystery. Kube-scheduler describe always tells you why. Then act, choosing the right lever, from a simple node selector all the way to topology spread and taints. And finally document QoS classes and priority, so you know which pods die first when memory gets tight, before the outage happens. So let's start with observe. Every time a pod is created, kube-scheduler picks it up and runs it through 3 phases. Filter throws out any node that simply can't host the pod. Wrong resources, wrong taints, missing volumes, unschedulable. Score then ranks the survivors 0 to 100, weighing things like resource balance, image locality, and topology spread. Bind is the cheap part. Write node name back to the pod, and Kubernetes takes over from there. The whole pipeline runs in milliseconds, and every lever you'll pull later is really just a plug-in in one of these phases. Now, the first lever you'll actually pull is node affinity. Node selector still works. A single label match like disk type equals SSD. But it's a blunt instrument. Affinity gives you a small DSL. Operators like in, not in, exists, GT, LT, and 2 flavors that matter enormously in production. Required is a hard constraint. No matching node, pod stays pending. Preferred is a weighted hint. The scheduler tries, but won't block placement if it can't satisfy you. That distinction between hard and soft is where cost and availability trade-offs really live. Node affinity. Pins, pods to nodes. Pod affinity changes the reference point entirely. You're now reasoning about other pods. Anti-affinity with a hostname topology key guarantees no 2 web replicas land on the same node, so one node loss doesn't take the whole service down. Topology spread takes that further. Max skew of 1 across zone keys forces an even distribution across availability zones. Lose a zone, you still have 2/3 of your fleet serving traffic. Flip it to pod affinity, and you co-locate, say, a cache next to its consumer for microsecond latency. The trade-off is honest. Tight co-location buys you speed and costs you zone redundancy. Now flip the polarity. Affinity has pods choosing nodes. Taints let nodes choose pods. You taint a GPU box with workload GPU, and 3 effect levels decide how strict that rejection is. No schedule blocks new arrivals, prefer no schedule is a soft hint, and no execute is the hammer. It evicts pods already running there. Only pods carrying a matching toleration get through. This is how you carve out dedicated hardware, isolate tenants, or keep workloads off control plane nodes. The scheduler enforces the boundary for you. Once placement is settled, the next question is who survives when the node runs hot. Kubernetes assigns every pod a QoS class based purely on how you set requests and limits. Match them exactly on every container and you get guaranteed last to be killed. Set requests below limits and you're burstable. Evicted before guaranteed when memory tightens. Set nothing, and your best effort. The first casualty of any pressure event, which is why it has no place in production. Layer priority class on top when you need explicit preemption rights for cluster-critical workloads. So let's compress everything into 6 reflexes you can actually carry into the on-call rotation. When a pod hangs, describe it first and read the events. The scheduler always tells you why. For any HA workload, topology spread across zones is the 4-line default that earns its keep the first time an AZ blinks. Always set requests so the scheduler can bin pack honestly and add limits to contain the blast radius. Use Taints for hard isolation on GPU or database nodes, attach a pod disruption budget to anything that matters, and drain with ignore daemon sets before you ever reboot. 6 habits. Each one turns placement from accident into design. And here's the whole lesson on a single page. 12 patterns grouped into the loop you've been practicing. The left column is observe and act. Describe a pending pod, cordon a node, set K8s, so eviction order is predictable. The middle column is shape the placement. Node selector for simple matches, spread constraints for zone HA, a pod disruption budget to guard voluntary evictions. The right column is the heavy machinery. Drain safely, express rich rules with node affinity, taint dedicated hardware, and reach for priority class name when preemption is genuinely warranted. Screenshot this one. It's your scheduling vocabulary in 12 cells. Now, before we close, 5 traps that all share the same fingerprint. They look perfectly fine on a single node dev cluster and then page you at 2 in the morning. Skip BestEffort by always setting requests, even tiny ones. Spread your replicas explicitly because the scheduler will happily bin pack 3 pods onto one node. Prefer preferred during scheduling unless you genuinely want pending on a mismatch. Test taints with no schedule before no execute. And count your actual zones before writing a topology spread that demands 3. Time to put hands on keys. 3 exercises, each one targeting a muscle you'll use constantly. First, force a pending pod by requesting 100 gigs of memory on your tiny kind cluster, then read the events. That's the diagnostic loop in its purest form. Second, deploy 3 replicas, watch them bin pack, then add a pod anti-affinity with hostname topology and watch them spread 1 per node. Third, taint kind worker as dedicated equals DB. Prove regular pods avoid it, then add a matching toleration and watch them land. Pending, spread, dedicated, 3 patterns, every production cluster. And that closes out scheduling. You now own the full placement toolkit, filter score bind, affinity, topology spread, taints, and K8s. And more importantly, you know when to reach for each one. Next up in Lesson 8, we shift from where pods land to how the cluster itself evolves. Kube-atom upgrades, version skew, draining nodes safely, and managing blast radius. Same SRE loop, bigger stakes. See you there.